Okay, guys. I hope we did okay yesterday on the worksheet that I gave you over vertical line test, which was not a test, folks. You're freaking out on me for no reason. But it's all good. At least you were paying attention to the heading of the paper. However, today, I can't answer your questions over that. However, whenever I come back on Thursday, I'll answer all questions over everything that I give you. I will not hold you accountable for anything like testing-wise or quizzing-wise until you're able to ask me. I've tried to go super duper slow so that I don't confuse anybody, but we'll see. All right. Yesterday was a vertical line test, and also was tell me if it's a function or not. Remember the ice cream candy problem, which next time y'all need to participate a little bit. Have fun with it. I'm not here, but I am here, so just like it. All right, here we go. Chapter 2-1, function rule. I'm going to do the same thing that I did yesterday, printing off your guys' notes for you. The majority of the notes are there for you. Just got to fill in where we start to do some math problems, okay? A function rule is an equation that represents y in terms of x. Basically, we've done this already, okay? We did this back in Chapter 1. We represented the nth term. Remember, you would have to find the pattern that went from what did we do to x to get to y. You asked yourself that question, and then you came up with the pattern, and then you expressed it in terms of n, meaning the nth term. Well, now you're going to express that instead of the nth term, but in y equals x, whatever we did the x, okay? That's a rule. For example, y is equal to negative 3x plus 6. In other words, what did we do to x to get to y? We multiplied it by negative 3, and then we added 6 units. Next example, y is equal to 2x minus 5. In other words, what did I do to x to get to y? I multiplied each x value by 2, and then I subtracted 5 units off of it. Do you remember that going on from Chapter 1? I know you do. It's just a matter of, actually remembering. So, okay. That's what we're doing. Function notation. Now, I don't want you guys to freak out, but all this is just writing y a different way. Okay? It's the same thing as having the name Christopher and we calling you Chris. Same thing as William and you call him Bill or Willem or Willie or Will or anything like that. Okay? Function notation. Another way to represent y, this is written as f of x. Okay? It's the same concept as if whenever you first meet your girlfriend or boyfriend's parents, you call them Mr. or Mrs. Then you get to know them, then you call them Harry and Sally, whichever one, okay? Same concept here. F of x is the very formal notation, whereas y is their first name. It's very familiar, all right? Write the equation y is equal to 2x plus 3 in function notation. Well, instead of saying y, what do we use? Hopefully you said f of x. So all I'm going to put in is I'm going to replace the y with f of x, and 2x plus 3 comes after. What this means is I've written a function f. I've named it f. I could have named it g. I could have named it h. Could have named it anything I wanted. I chose to name it f, and I'm telling you that the variable that is inside the equation is x. Could I have had g of w? Absolutely. That means I have a function g with a variable w. Don't get yourself hung up on there. All that x means is that there is technically an x inside here. That's all it means. Okay? And I wrote on here, replace the y with f of x, and you have f of x is equal to 2x plus 3. That is all you're doing, folks. Okay. Next. Write the equation y is equal to negative 9 plus 4x in function notation. I'm going to give you guys a minute. Please do so now. Okay, you should be done. According to the last example, I get rid of my y, and in place of it, I'm going to put f of x. Why do I use the x? Because that's what y was expressed in. Y was equal to something with an x in it, so that's why I must use the x inside the parentheses here. And negative 9 plus 4x I bring down. That's done. How many of you got it? Come on, participate. Put your hands up and actually show me, and you put a big smile on your face, peoples. Okay, how many people did it? Yay, I'm so happy. If I had candy, I'd throw it at you. Okay, moving on. Actually, that was a lie. I probably would have eaten it in front of you, wouldn't I have? Just being honest. Using functional notation. Functional notation is used for evaluation of a function. Okay? The whole point of writing things as in functional notation is, what are we going to do with it? Okay? Well, what we're going to do with it here is we're going to do it to evaluate the function. In other words, all this is our old XY tables. It's another way of doing our XY tables. So, given f of x is equal to negative 2x plus 5, what is the output value for the inputs? Ooh, I used two more words in there that I have not talked about yet today. However, I did talk about them yesterday. Those two words are what? This is the part where you actually participate and respond. They are output, which is spelled incorrectly. Gotta love it. And input. Okay? Oh. There, I fixed it. Okay? Output is also known as your y value, and input is also known as your x value. Remember that? You should. Yes, great. Okay, so f of x is equal to negative 2x plus 5. What is the y value for the x being negative 3, 0, and 1/4? Do you see how math is all these? We have synonyms for everything, and that's okay. You just have to be able to understand what it means. So what this means is you plug and chug the values negative 3, 0, and 1/4 for x. For x. Everywhere you see an x, write your answer as an ordered pair. That is crucial, okay? Why is that crucial? Because whenever you plug in something for x, you're getting out y. Well, how do we interpret that? Well, graphically, we interpret that by being a point on the xy plane, okay? So you have to make sure that you're interpreting your data and understanding what it means. So let's go ahead and do this. I want to do f at negative 3. Well, what is f described to be? F of x is described to be negative 2x plus 5. And in place of the x that I had here on the left-hand side, what's in its place? Negative 3. So every place I see an x, I plugged it in on the left being negative 3, but I never plugged it in on the right. So what you're going to do is simply plug and chug. Negative 2 times negative 3, and calculate. 6 plus 5 gives you 11. That's your x value. So that's going to be the ordered pair, 11. I lied. That's your y value. Sorry about that. So that's going to be the ordered pair what? Well, remember this was x. And if that's y, then I have the ordered pair, negative 3, 11. This is what I'm looking for, folks. Okay? That is what I'm looking for. Let's do it again. Okay? What is f defined to be? Why f? Because it says f at 0. So I take my f function, negative 2x plus 5, and every place I see an x, I plug in 0. Negative 2 times 0 is gone to give me 5. That is my y value. Am I done? Is that what I want? No, because the directions said to put it in an ordered pair. So my answer is going to be, well, what was x? 0. And what did my y turn out to be? 5. Now I'm done. Okay, we'll do the fraction. Woo, fraction. It's okay. No stressing. Remember, we already know how to deal with fractions. Negative 2, plug in the 1/4. Over 5. Put the negative 2 over 1. What happens, folks? I hope you said cross cancel. The 4 becomes a 2. This becomes a negative 1. To give me negative 1/2 plus 5. Now let's think logically. You have $5. You give half of a dollar, which is what? 50 cents to somebody. So how much money do you have? Well, that's going to be $4.50, which is the same thing as, remember the circle rule, 2 times 4 is 8 plus 1 is 9/2. How about that for common sense and knowledge? Good job. Okay, let's do it one more time. This time, I give you f of x, which is a homework problem, y'all. This is a homework problem. Given f of x is equal to negative 2x plus 1/3. What is the output for the given input? In other words, what is the y value for the given x value? Write your answer as an ordered pair, exactly what we just did. All right? Well, I want to know a at -2. Well, that actually means that I'm doing f at -2, which means I'm actually looking at the function 2x plus 1 over 3 with a negative. Where am I going to put that negative? Where am I going to put that negative? Where am I allowed to put it? Can I put it to the top, to the bottom, or to both? Top, bottom, or both? You should be yelling something out. Now, I'm assuming there are some people in here who said both. No, 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 no. Top or bottom. If you put it to both, a negative divided by a negative is a positive, which means you've changed the problem. So this is going to be the same function as 2x plus 1 over -3. I'm putting it to the bottom because if I put it to the bottom, it's a lot easier for me to be able to do my calculations. I don't have to multiply by a negative up top. So now I plug in a -2 right here. And that's going to give me 2 times -2 gives me a -4 plus 1 is going to give me a -3 over -3, which gives me 1. So what's my answer? Not 1, but the ordered pair, what? -2, positive 1. Okay, good. Same concept. This time, I'm evaluating at 0, which means I'm doing f at 0 for the function 2x plus 1 over -3. Every place I see an x, I plug in 0. So that's 2 times 0 plus 1. That's gone to give me a -1/3. Am I done? Ordered pair. My ordered pair is going to be 0, -1/3. Okay? Same thing here. I'm going to do my f at 5. So 2x plus 1 over -3 gives me 2 times 5, which is 10, plus 1 gives me 11 over -3. Do I care that that's a fraction? Nope. As long as it's reduced completely, I'm okay. So I have the point 5, -11/3. Done. Okay? This is like the front side of your worksheet today. Okay? Plug and chug, calculate, put it in order pair. We good to go? Great. Back side. I'm not wasting time today. Reading domain graphically. Graphically means we're talking about looking at a graph. Domain is talking about your x values. Remember all the synonyms for x? Okay? So I want to look at my x values on this graph. I want to read it from left to right. More importantly, I want to find the smallest x value that has a corresponding y value to it, which means I need to go all the way to the left. I need to go all the way to the left. Okay? That's my smallest x value. And then I need to find the largest x value, okay, that has a corresponding y value to it. That's on the right. Okay? Domain is the x-axis. We read it from left to right, and we're looking for only the x values that have a y value. Now understand, the y values might be off the graph into the ceiling or all the way down to the floor. It doesn't matter, you just have to find them. Now obviously, if domain is the x values, reading from left to right, then we also have the range, which is going to be read from bottom to top, because range is also known as your y values. Because range is also known as your y values. Okay? Now, we're going to find the smallest y value, and that is going to be at the bottom. And again, that y value needs to have a corresponding x value. Okay? And we're going to need to find the largest y value, and that's going to be right at the top. All right? Now, let's dig in. This is the problem out of your book. Now, remember, I want to find the domain and the range. You're going to struggle with this a little bit. So if you need help with it, I'll be more than happy to help you on Thursday whenever I get back. Just try your hardest to understand it, okay? The domain. In other words, as x gets really small, do you see the points here? Do you see there's a point that corresponds there? There's a point that corresponds here. X is getting smaller, isn't there? Do you see that it stops? We can't see anything else. But what happens is, look at those arrows. That means it actually extends off the page, into the ceiling, into the sky, past the clouds, into the ozone layer, out into space. You get me? Meaning, my smallest x value is way down here. So my smallest x value is negative infinity, right? Meaning the absolute smallest number in the entire world. And then my largest y value, or largest x value, see, I still have an x with a y. I still have one. I still have one. Is going to be clear over there, okay? Meaning going to positive infinity. So my domain is x's and elm of the reals. In other words, it can be any real number you can possibly think of, okay? Because of those arrows. Those arrows are key. Now, the range. How do we read the range again? We read the range from the bottom to the top. So what is the absolute lowest y value? I said y, not x, okay? My absolute lowest y value is going to be the actual minimum, the hump, not the hump, the valley, I'm sorry, the valley of the graph. The valley of the graph. Well, that valley, the lowest y value, this is the point 0, 0, which I want my y value right there, which is 0. So it starts at 0, and then what happens? What happens to my y values? Do you see? Here's a y value clear up here. Here's a y value clear up here. There's one clear up in the sky. There's another one clear up in space. So is there ever a max to my y values? Nope. So that means it starts at 0, okay? But it can only get bigger than that. So it's greater than or equal to 0. Y is greater than or equal to 0. Okay, it starts at 0, but there's no cap on it. It can go on forever. Let's do another one. So now I'm looking at domain. Domain, I read from which direction? I read from left to right. Well, here's a point. Here's a point. This point is 1, 2, 3, so that's negative 3, 0. This point over here is going to be 1, 2, 3, positive 3, 0. Does it get outside there? Is there any other bigger x values? Or any other smaller x values? No. So what this means is that my graph, my x values, are trapped between negative 3 and positive 3. Remember the trapped concept? When you're trapped, what signs must you always use? Well, when you're trapped, negative 3 is always less than positive 3, and x is in the middle, and since they're closed dots, I put less than or equal to on both of them. Okay? The range. The range is going to be read from which direction? From bottom to top. Okay. Well, that puts me right here and right here. Well, that point down there is going to be 0, negative 1, and this point up here is going to be 0, positive 1. Yes? So again, what's trapped this time? Is it X or is it Y? Well, it has to be the range values, and another synonym for range is Y. So Y is in the middle this time, and it's trapped between my lower value of -1 and +1. Well, -1 is always less than +1, and it's closed dotted because it's allowed to equal them, so you're done. Your range goes from -1 and taps out at +1. It can't go past +1, okay? This is tonight's homework problem. Oh, no, it's not. This one needs deleted. There's tonight's homework problem. I already did the other one. Find the domain and range graphically of the graph. Okay, well here we have a line. What do we know about a line? Hello, what do we know about a line? If you said it goes on forever in both directions, then you are right, because do we see this arrow and this arrow? Which means if it goes on in both directions, it's going all the way up here in space and all the way down here in space, right? Which means what? That means whenever I'm doing domain, my smallest x value that has a corresponding y value, do you see it? It's -infinity. And then over here, it's positive infinity, so that means x is an elm of the reals. In other words, there is absolutely no start or end to this line. Okay, it goes on forever in both directions. Well, that's pretty cool, because now I'm going to ask you about the range, which deals with my y values. Well, can you find the absolute smallest y value? Well, I think it's right here, but then I extended the line, which means it can be right here, which I extended the line, which means it's right here. And then do you see it extended down into the floor? Do you see it extended down into the basement? Do you extend it down into, like, negative sea level? So does it have a lowest y value? Nope. So let's go over here to the x, to the positive side. Well, here's a y value. Here's another y value. Here's another, and another, and another, and another, and another. And then it goes off into space. So do I have any max there? I do not. So y is an elm of the reals also, because it goes from -infinity to positive infinity. Now I understand that this is something that you're going to struggle with. I'm not as concerned about this. This is something we do a lot in pre-calculus, but I wanted to introduce this stuff to you because it does touch on it in your book. And it's a good thing for you to be exposed to it. So, tonight for homework, Chapter 2-1, continued. And you owe me the domain and range worksheet, along with the evaluation. Okay? Any questions? I promise I will take care of everything whenever I get back. Have a great day, guys, and be good for Mrs. Price. And remember, if I get a bad report on you, your life is going to be miserable whenever I get back. So, friendly reminder, be good. Have a great day.